So a couple announcements. Your project is due on Thursday. Your presentation is on Thursday, and then your paper is due on Friday. Okay. So on Thursday, I'm going to ask that all of you try to come right at the hour at 8 o'clock instead of at 8:10, because we do have a lot of projects to run through. And I do want the most time possible to run through the projects. Okay, so if all of you can try to come on time for the presentations on Thursday, that would be really appreciated. Okay, and do remember that your project presentations should be approximately 5 minutes in length with 1 minute for questioning. And yeah, it can be in really any format, okay? Video, PowerPoint, anything, but it needs to be a visual presentation. Does that make sense? Any questions? And I've been getting a lot of good emails from all of you about the project. Sounds like all of you are on the right track, which is great. And I do hope to see high grades for your project, okay? So today you were supposed to read an article and do an article reflection for this morning at 8 o'clock. Hopefully everyone did that. So I do want to begin by talking about that briefly. So anyone want to share with us a summary of what they read? Anyone? Just feel free to unmute yourself and give it a go. Anyone? Okay, so today the article was basically telling us that the older a country is, right, the lower the spending multiplier tends to be. Did you guys get that point? Anyone have any idea why that's the case? Why the older your population is, the lower the spending multiplier may be? Anyone wants to give me a verbal explanation? Any thoughts? Basic idea is, oh, sorry, someone wanted to go, please.
Oh, didn't the article say that it was because younger people have a higher tendency to actually spend the money that they're given?
Yes, that's absolutely correct, right? So when we're younger, we tend to like to, go out, eat with our friends. We like to buy the newer clothes to keep up with fashion, stay cool with our friends, right? We want to get the newer sneakers that are out there, and we want the latest iPhone that Apple's making, or Samsung Galaxy, whatever phone you're buying, right? But older people, they tend to have lower marginal propensities to consume because there are just less things for them to purchase, right? So my grandma is 92 years old. She's living with us. Very nice lady, but she's quite old, and most of her time is spent, in the house, sleeping, eating, walking around. She's not really going out and buying herself clothes. She's not going out and buying herself the latest iPad or the latest iPhone, things like that, right? But me, her grandson, my old computer was just about to die, so I'm very thankful that the United States government just passed a very nice stimulus check to everyone or almost everyone, for like $1,400, right? Which helped me in purchasing a new laptop that I'm able to teach you on today, because my old one just died last week, which is unfortunate. But you see, like younger people, when we get these money, right, we have places to spend it, and we tend to spend it quicker, and we tend to have a higher marginal propensity to consume. Does that make sense? And we'll see today why, okay? And I hope you were paying attention in lecture, but if not, we'll definitely review that concept today of why, okay, higher marginal propensities to consume tend to lead to a bigger multiplier effect, and also the vice versa, okay? Awesome. So, and also thank you to all of you that filled out the mid-semester evaluation. It's very helpful to get some feedback from all of you. One feedback I did get is some of you don't like running ahead of lecture and just like to review lecture notes. I totally understand that. But today I have to apologize, and we do have to run a little bit faster than lecture because on Thursday is your country presentations. So we don't really have a section to review Thursday's material, right? And right after, when you come back from the spring break, is the midterm review. And right after the midterm review on Tuesday, on Thursday is your midterm exam. Okay, so today is kind of like the last day we have to go over new materials. So today we're going to be running a little bit ahead of lecture. And for those of you who don't like that, I do apologize in advance. And I hope you understand. Okay. So anyways, we're going to get started. I'm going to share my iPad. And we're going to do a mega kind of review of what we have been doing up until this point. Okay. So what we have been doing is, I hope you remember, is in equilibrium, short run equilibrium, okay, your aggregate demand equals to your Y. So what is aggregate demand? Aggregate demand is equal to C consumption plus I investment plus G government spending plus net exports, NX. And net export is just GX minus IN. Okay. And we have further developed each of these equations. We said C is equal to the C naught plus CY times YD. And we defined YD as Y minus T. Okay. And how are we defining taxes? Well, we're defining taxes as Y minus TA plus TR. Okay, we can further expand this to Y minus TA naught plus TR naught, okay, minus T times Y. So what we're doing here is basically, this is kind of like a tax shock or a shift in your taxes paid. Okay, this is your transfer shock. And TY is the amount of tax you have to pay based on income. And for simplicity of math, we're assuming a flat tax, as you're noticing that T is uniform throughout all income levels. If you have a progressive tax system, which means richer people pay a higher percentage of income tax, right? Your T function will get more complicated. So regardless, we have this equation for YD, so we can rewrite C equals to C naught plus CY times Y. And I hope you see that there's a Y and the minus TY, right? So I can write Y times 1 minus T, right? So Y times 1 minus T minus TA naught plus TR naught, okay? So with this equation, we have our consumption function. Further, we also have our investment function, which is just I naught minus IR times R. Okay, G we say is exogenous, right? And lastly, we have GX minus IN. Okay, GX we define as GX naught plus XFYF plus X epsilon epsilon. And we define epsilon as epsilon minus epsilon R, R minus RF. Okay, so we can write out GX as GX naught plus XFYF plus X epsilon naught minus X epsilon R times R. We have this term, right? And plus X epsilon RF. Okay, we have already done this derivation before, so I'm not going to get into too much of the details. And then IM is equal to IM naught plus IM Y times Y. Okay, so all things put together, you have aggregate demand equals to C naught plus CY times Y plus CY TR naught minus CY TA naught minus CY. Sorry, I forgot the. So I'm going to write CY times Y times 1 minus T. Okay, that's just your C function. I naught minus IR times R plus G naught plus this whole thing, GX naught plus XF YF plus X epsilon epsilon naught minus X epsilon epsilon RR plus X epsilon epsilon RRF minus IM naught plus IM Y times Y. Okay. I know this is very complicated. I just want to run over all these notations really quick. It's really important all of you understand what each of these things mean. C naught is kind of your consumption shock or shift, right? This is your marginal propensity to consume. Y is your income, right? T is your tax rate. TA naught is your autonomous tax or your baseline tax or your tax shock. Okay, TR naught is your transfer payment shock. For example, like the stimulus check, right? It's a transfer payment shock. I is your investment. I naught is your baseline investment or shocks. Okay. IR times R is your sensitivity to interest rates. Okay. G is just G naught. This is government spending. Okay. GX naught is your exports shock. XF is sensitivity to foreign income, which is YF. And X epsilon is the sensitivity to exchange rate. Okay, and your exchange rate is defined by a baseline exchange rate. And then sensitivity to relative interest rates, which is defined by domestic interest rate and foreign interest rate. And then IM is defined by this import shock plus sensitivity to income. Okay. So someone told me they really wanted to see this, and I hope this helps you a little bit to clarify what each of these things mean. I think on your exam, the professor will very likely give you these gigantic equations and then ask you to talk about the effects of certain things. And it's really important to you for you to understand, okay, what is affecting what? Okay. Great, I'm glad it's helpful. Okay, this is like a kind of like a summary of what we did in the last 2 weeks, right? So with this in mind, any questions on this so far? No questions? Okay, so let's move on, okay? So in the short run, we say, okay, in equilibrium, right? Y equals to AD, okay? So I hope you can notice that for AD, we can pull out a y term from here and also from here, okay? So we have cy times y times 1 minus t minus IMY times y. Okay, and then I have all these other terms. Let's draw that in blue. Okay, for simplicity's sake, let's just say all that blue terms is just an A. Okay. So we can write aggregate demand as y times cy times 1 minus t minus IMY plus A. Okay. And this thing is what we call the marginal propensity to expend. Or MPE, okay? It's cy 1 minus t minus IM times y, or IM sub y, okay? So I hope you can see at equilibrium, and remember that's AD equals to y, you have y equals to y times this MPE term plus A, right? With simple algebra, you have y 1 minus MPE equals to A. So y equals to is A over 1 minus MPE. Okay, and just remember your A is all these other terms besides these two. Okay. Any questions on that? So the next thing I want to point out is, okay, we know MPE is equal to cy 1 minus t minus IM sub y, okay? So cy is your marginal propensity to consume, and this is 1 minus your tax rate. And this is your sensitivity to changes in income of exports, okay? Or sensitivity of exports. I think that makes better sense. Okay, so I hope what you can see here is MPE is also something between 0 and 1 because CY is something between 0 and 1. Okay. 1 minus T is also something between 0 and 1, and IMY is something between 0 and 1, right? So a decimal minus a decimal is almost certainly, less than 1. Okay, then why do we argue that it's greater than 0? Because CY times 1 minus T is usually pretty high, usually pretty big. And IM is usually pretty small. Because if you really think about it, IM is kind of embedded into the CY term, right? CY is always greater than your IMY because your imports are basically part of your consumption most of the time, okay? Of course, your government can also import from other countries. Your investment can also import from other countries, but most of the importing is for consumption, right? So this term is pretty much always, and 1 minus T is pretty close to 0.8 or 0.9. So this term is usually around 0.6, 0.7, it's pretty high, and IMY, very small. Okay, let's say I give you an extra $1,000. The amount you will spend on imports likely very small compared to your spending on other domestic consumption items. Does that make sense? Okay. So what we can draw out here is a Keynesian cross named after John Maynard Keynes, who came up with the idea that in your short-term aggregate demand equals to Y. And what the Keynesian cross is, you have aggregate demand on the Y-axis, and then you have Y on your horizontal axis. And we can first of all draw a horizontal line of AD equals Y, which is your equilibrium. This is like a level of all possible equilibriums. Right? I hope that's not too hard. And we also said, okay, aggregate demand equals to 1 minus, sorry, my bad. Not 1 minus, just MPE times Y plus an A level, right? So we can have a random A level. And then this we said is less than 1, between 0 and 1. Right? So we have a flat slope, flatter slope than 1. And where these two things cross, which is the brilliance of Keynes, is your equilibrium level. Okay? It means your output equals to your aggregate demand. Isn't that nice? Okay. Any questions on that? And I hope you will start asking the next interesting question, which is, okay, so what if this thing shifts up? Okay. I hope you can see from here, if it shifts up, your new equilibrium is at this level. So what's going to happen is this is going to happen. You're going to move up here, and then you're going to converge to here, here. So how that cycle works, I will explain this in great detail to you, or I'll try to explain in great detail, is, for example, if my aggregate demand goes up by, say, $100, okay? And let's assume my MPE to be equal to 0.5. It's arbitrary. I just want to show an example. Okay. So when my aggregate demand goes up by 100, then my Y goes up by 100. Okay. Because my output is going up, my demand is going up, then therefore my output's going up, which generates additional income, things like that, right? So with Y going up $100, this can go into several places. One is taxes. Boo, you have to pay taxes, right? But we also know that it can go into consumption. Okay. And consumption, you can either have imports or you can buy domestically produced goods and services. If I decide to purchase domestic goods and services, this is another increase in Y. Because my consumption is turning into somebody else's income, and they in turn can turn that into their consumption, their expenditure, which in turn becomes someone else's income and someone else's expenditure, so on and so forth. Okay, so what this MPE is telling me is, first time, Y goes up by 100. Okay, but because of losses to taxes, and imports, okay, the second time, y only goes up by 0.5, okay? 0.5 times the first time, which is 0.5 times 100. This is where your MPE comes in, okay? MPE is basically telling you in each round approximately what percentage of your increase in y becomes another round of increase in y, okay? You can say 1 minus MPE. These are the things that's lost to tax and imports, okay? So this is round 2. In round 3, you have, this is 50, right? You will experience half of that times 50, which is 25. Next round, you have 0.5 times 25, which is 12.5. Round 5, 0.5 times 12.5, which is 7.25, etc., etc. Okay, so I hope you can recognize that every time this is just decreasing by 0.5. And if you have taken a statistics class, you know that this is just a geometric sum, right? Of 100 times 1 over 1 minus 0.5, which is equal to 100 times 2, which is $200. Okay, so in total, your change in y will be $200, and your change in aggregate demand will be $200 at equilibrium. Okay, assuming we're starting at equilibrium and moving to another equilibrium. So let's remember again that the MPE is equal to CY, 1 minus T minus IMY. Okay, so this thing, I would say the taxes, old people, young people don't really control that. Okay, you and I don't really have the power to set the tax rate, but what we do have control over is this thing. So what we're claiming is old people have low C sub y, while young people tend to have higher C sub y. Okay. So in total, old people have lower MPE and younger people have higher MPE, right? And if we translate this to the multiplier, so what is the multiplier? It's just a geometric sum, which is 1 over 1 minus MPE, okay? I have a lower MPE, which means multiplier is smaller. Okay, higher MPE, multiplier bigger. And why? This is because your denominator is smaller. Okay, remember if MPE is equal to 0.5, is 1 over 1 minus 0.5 equals to 2. If MPE is equal to 0.8, you have 1 minus 0.8, which is 1 over 0.2, which is 5. Does that make sense, everybody? Any questions? Okay, if no questions, I'm going to move on to introduce a new topic. Okay. So a new topic is quite straightforward, I hope, for you. And the new topic is the IS curve. Okay. What's basically showing is y is negatively related to r. We have y on the x-axis and you have r on the y-axis, okay, has a negative relationship. And you may ask why. Well, because at equilibrium, right, y equals to aggregate demand, which is equal to C plus I plus G plus NX. And do remember that if R goes up, I comes down, right? And also your exports come down, which means, okay. Interest rate goes up means appreciation, lower exports, and also lower investments. Okay. This is basically the idea of the IS curve. And we're going to try to derive one right now. So what we have here is have a function for C, have a function for I, have a function for G, and a function for NX. So at equilibrium income, Y equals to AD equals to C plus I plus G plus NX. What we have here is then 600 plus 0.8 times 0.8, 0.64 plus 17,200 minus 274,000 R plus 2,000. Okay, and then NX is right here. 40 times 95, according to my calculator, that is 3,800. Now 30 times epsilon, so 30 times epsilon, which is 40 minus 1,000 R, and negative 1,000 multiplied by negative RF, that's just plus 20, which is 0.02 right here, right? So we have 30 times, this is 60, okay, plus 1,800 minus 1,000 times 30, 30,000 R. Okay, if you're feeling lost, this is just algebra. And this is minus 0.15 Y. Basically, I'm just distributing the terms, multiplying the terms over, adding and subtracting. Okay, I hope you're not really confused. Nothing too complicated here, nothing too fancy. And we can combine like terms. We can move all the y's to the other side, right? So I'll have y minus 0.64y plus 0.15y, which adds up to 0.51y. Okay, so 0.51y is equal to 600 plus 17. All these numbers add up to, according to my notes, 25400 minus 374,000. Sorry, 304,000. Okay. And we just multiply both sides by 1 over 0.51, and we have y equals to 49803.9 minus 596,078.4 R. I have no idea why these numbers are not rounded nicely. But any questions on that? Okay, we're just moving things around. So when you see write an expression for something as a function of real interest rate, that just means isolate all the real interest rates on one side and your income on the other side. Okay, so this is y in terms of R. Does that make sense? And I do hope you see that there is a negative relationship here, right? So it asks, what is delta y delta R? Well, it's just simply the slope, which is negative 596,078. If you prefer calculus, it's just dy over dr, which is still equal to the same thing. Okay. What this means, if we have an 100% change in r, how much y will come down? Okay. More useful would be this thing, delta y over delta r times 0.01, as it gives you a 1% change in interest rate. Does it make sense? I hope that's not confusing anyone in particular. Okay. So this question asks, okay, what is the equilibrium value of income when real interest rate equals to 4%? Well, I just plug in numbers to 49803.9 minus 59607.8.4 times 0.04, which yields 25960.76. Okay, which is about right here. And when it's at 0.06, same thing, but multiplied by 0.06, which gives me 14039.2. So at 6%, I'm at 14,000, which is approximately right here. Okay, so I can draw approximately a straight line. And you can do better than me, okay? Anyway, the idea is y is negatively related to r. Okay. So question 9 is very similar to question 8, except that cy now equals to 0.9 rather than 0.8. So all we have to change really is we notice, okay, this thing is 0.9 instead of 0.8. So this thing, this fraction, this decimal point, instead of 0.8 times 0.8, which was 0.64, now we have 0.9 times 0.8, which is 0.72. Okay, so we do the same exercise as before, but except we don't subtract 0.64 anymore. We do y minus 0.72y plus 0.15y, which yields to me 0.43y. Okay, all the other terms is the same, right? So this is the only term I have to worry about. So what I end up with is 0.43y on the left-hand side equals to this expression on the right-hand side. Okay. And I divide both sides by 0.43 and I have y equals to 59069.8 minus 706976r. Okay. And this handwriting is horrible. This is a 0 and this is a 6. So now I hope you can notice that delta y, delta r is equal to dy dr, which is negative 706976. So the result is a higher MPC leads to a more sensitive response of y to r. Does that make sense? Because before, if r goes up by 1%, your y only changes by about 6,000, right? But now it changes by about 7,000. So your y changes more dramatically with the same magnitude of change in r. So we say it's more sensitive compared to before. Okay. And I won't do this problem because it's just plug and chug again, but into this new equation. Okay, so you can do that on your own. Last question is same expression as before, but for example, let's go back to question 8. If interest rate is at 4%, but real GDP is at 25,000, and if real interest rate is at 4%, GDP is at 27,000, what's going to happen to inventory holdings? That's the good question. Okay, so our equilibrium level at 4%, remember, is 25,960. Now it's saying, okay, what if we're at instead 25,000 or 27,000? When we're at 25,000, this means real output is less than, right, equilibrium output, which is equal to your aggregate demand. So if your output is less than your demand, then what do? Okay, what you will do is you dig into your inventory and make it up. Because people are demanding so much at that price level, okay, that you kind of have to dig into your inventory and find whatever you have and sell that. Okay, so you go back here. And I hope you remember that inventory depleted means I is going down. Okay, but I going down usually means your C is going up or your GX is going up. Right? Your inventory is either being sold to domestic consumers or foreign consumers, and sometimes to government, sure. Okay. But the point is, you deplete your inventory to fill that demand. And the opposite is true if your real output is greater than aggregate demand. You're building up inventory in this case. Because people are not demanding so much as what you're producing, right? So you're just going to accumulate inventory. Okay, accumulate I. Does that make sense? And when your real output is less than aggregate demand, then you deplete that inventory you have previously built up. Okay. Any questions? I know that was a lot, and this is definitely a lot of math, very tricky. The most important thing you all need to understand is, and I will say this again, is you need to recognize what each of those letters mean, okay? What each of the characters, what each of the variables are representing. If you get those, I think, and are able to match it to like real life problems, so I hope you are not limiting your scope to, okay, this is T, this is G, this is I, this is R, this is epsilon. But you're able to interpret what is given to you into the question. For example, in the problem set, you had 3 examples, right? Government giving people student money, government cutting taxes, and government installing new ventilation systems, right? So you're asked to match each of these into either TR, TA, or G, right? Something similar could come up at the exam, asking you to match a certain activity to a certain variable. So I encourage you over the spring break not to kind of slack off on Econ 100B, rather to think about, what can lead to changes in GX naught, what can lead to changes in epsilon naught, what can lead changes to I naught, C naught, things like that, okay?